Okay. Good morning, everyone. Good morning, Japan. Good evening, Japan. Today, I would like to status in Japan and ongoing work related to ISO. This slide represents the contents of today. The first part is status in Japan. Especially here, I would like to show you about most important law and act for buildings. Of course, it is related to airtightness of ductworks. And the second part is ongoing works. I would like to move to the first part. As I mentioned, for buildings, we have important laws or act. The first of all, I'd like to show you about the building standard law. It is mandatory and very primary law concerning building codes, and it requires very minimum standards concerning the site, construction, and the use of buildings, and of course, equipment. And in order for enhancement of the standard, we can see only the description on airtightness is for just fire dampers. So, very unfortunately for us, overall description of airtightness of ductworks does not exist. I'd like to move to other act, Building Energy Efficiency Act. You can understand it is similar to EPBD. So we have standard in the act, of course, and the standard requires calculation of envelope performance, like as U value, something like that, and primary energy consumption. The target of this act is newly built buildings only. The calculation, especially for primary energy, is executed in design term. And it becomes full obligation in 2020. I would like to show you about the official program for calculating the primary energy. As you see, we have English version. And please see upper part. Okay, here you can see the envelope, heating system, cooling system, ventilation. This is the heat exchanger. I mean the heat recovery ventilation and lighting, something like that. So ventilation is most related in the airtightness of ductworks. So I would like to show here. Here we can select a type of ventilation, and some of them employs, of course, duct. But you may not see airtightness here. And we can input a specific fan power here. And as I mentioned, some specification values of heat recovery ventilation can input here. But we do not see airtightness of ductworks. So I have to say about the airtightness of ductworks. Airtightness of ductworks are not required. And at the same time, airtightness of buildings are not required too. But many housing manufacturing companies do the test of airtightness of buildings during construction time. We do not test of ductwork airtightness, unfortunately. We have no regulation at all. So why we don't have such kind of regulation? What makes the present situation? I would like to show you. You can see red text here. All of them are law or act. They are very strong act or law. First of all, in the design term, as I already mentioned, Building Standard Law and the Building Energy Efficiency Act is given by Ministry of Land, Infrastructure, Transport, and Tourism. So design specification values are checked or inspected by agencies, but as I mentioned, airtightness is not included. The reason is not so difficult because it is impossible to measure it during design time. That is only reason, I guess. On the other hand, operational term, we have act on maintenance of sanitation in buildings. It is given by Ministry of Health, Labor, and Welfare. A measurement of indoor air environment using, for example, this kind of measurement instrument. Indoor air environment has to be checked every 2 months or more. Measurement items are, for example, carbon monoxide, carbon dioxide, air temperature, air humidity, formaldehyde, and so on. The targeting building's floor area is greater or equal to 3,000 square meters. This act is since 1970, and it is not included for housings. But using the measured value, maintenance of facilities are handled. So existence of this act or law, the indoor air quality or energy performance is, what can I say, watched. So we don't have, at the moment, some regulation on airtightness of ductworks. This slide is a sort of summary in Japan, how to achieve energy conservation or and good indoor air environment. So to achieve energy conservation and good indoor air environment, we can select 3 methods. This is just my idea, but first method is inspect design performance. It is during design time. And method 2 is inspect indoor air environment itself. I guess it is important. And method 3 is inspect the performance of facilities. And as I mentioned, method 1 and method 2 is selected by Japan using in the act or law. So unfortunately, I don't have any data of ductwork airtightness in Japan, like last automaton, unfortunately. But of course, requirement of airtightness of ductwork makes the Japanese situation better, I believe. I move to a last part. Ongoing work of ISO TC 163 SC1 working group 10. So at the moment, four things are going. Measurement of airtightness of building, airtightness of building elements and assemblies, evaluation of the measurement of airtightness, measurement of ventilation rate. And especially on ductwork, the work is just started, but we think the status important task to be settled. You can see this in this slide. So especially I would like to say about task to be settled, that's third one. Overviewing of the status in terms of the code and the regulations, and the practical measuring system procedures and so on should be shown. This is my last slide. We are now accumulating knowledge. Especially for me, I am very interested in the product, duct components, and measurement instruments. I'm very interested in, especially here. And the standards, last presenter, Lars Mattsson, kindly showed us more than here. And even in Japan, this slide is, well, the lecturer was Ray. When Ray came, he kindly showed us European knowledge, and it was so helpful for us. Okay, that's all. Thank you very much.